Hi, welcome to this TouchDesigner tutorial where I'll show you how to make this system which creates this wavetable effect where each of these waves frequencies corresponds to an image's values. So you can see this how it looks with different inputs. And you can change the size of the grid itself, also the ratio of each of the tiles of the waves, and also change the ranges of the frequencies. So you can have some really nice high frequencies or keep it low. I'll also show you how to make this auto reactive. As always, the file for this project will be available on my Patreon. So if you'd like to support me, it really helps me out and allows me to keep making these videos. You can go to my Patreon and get these files from there. Okay, I think we can begin. I'm gonna delete everything. And let's start with a constant. So I can have all my parameters. I'm gonna have my resolution on X and Y, my resolution of the grid on X, the levels, which will be the amount of different waves that we're gonna generate. I'll show you what I mean in a second. Also the tile ratio, and minimum cycles and maximum cycles. And let's have another null with let's select this and right click the background and collapse selected so we can compute the rest of our parameters. Fill this up with make it 1080 by 1280 with a width of the grid of 10. Let's make 10 levels and the tile ratio make it 0.5 and make it between 1 and 10 cycles. Now let's go inside of here. First, we're going to calculate the ratio to the proportion of our image with these two parameters right here. So I'm going to select those in opposite order as they are here. So first resolution Y and then resolution X. I rename this to ratio. And now with a math, I can combine these channels with divide. And there is a ratio. I can add a merge to join this. There you go, ratio. Now with our ratio, we can calculate the resolution of our grid in Y. So let's select that, select, and grid X, I'm gonna rename that to grid Y, and we can combine these two with a math. I'm gonna switch the order so it gets this name, and combine chops with multiply. There it is. But also we need to take into account the ratio of the tiles. So I'm gonna select that as well. Select here the ratio, and use another math to divide these two. So combine chops, divide, and that is our resolution in Y. But we need it to be an integer, so I'm gonna change this to round. And there is rounded, and we can join that in with the merge. That's all we need to do here. We can change this null name to null data. And now we can start creating. First, we need our grid that we're going to use for instancing. I'm going to do that with a ramp. That is going to have the resolution of our grid right here with X and with Y. Pixel format, I'm going to change it to 32-bit mono. And I can copy and paste this and set the second one to vertical. Now let me combine these two with a reorder. Change the reorder pixel format to 32-bit RG. And here the green channel is going to be set to the second input. And there's a ramp. We can see if I switch this to points, there's a grid, but this isn't quite right since the proportion of our image is 1080 by 1280. This is the ratio. So it shouldn't be a square, it should be a rectangle, a vertical rectangle. So to get that, I'm going to add a math. And the range of the green channel should go, instead of 0 to 1, to 0 to our ratio. And now you can see there's a rectangle. And if I change the tile ratio to 1, so it's squares, you can see it's a grid of squares right there. Let's change it back to 0.5. That's good. Pause for position. And now we can start. We have this information that we're going to use for instancing. So let's start with that instancing setup. Let's use our rectangle. And this rectangle should have the same proportions as our tiles, since these rectangles are our tiles. Let's change to that. And this should be whatever size it is in width multiplied by the ratio. So I'm gonna copy this right here just to copy it, and we can multiply those two. So now if I change the size, it remains that same ratio, and the size is gonna be 1 divided by our grid width. So it perfectly covers all space, right? Okay. Now I can do geometry. Always remember that it's important here to not add the geometry on its own, because it won't have the input by default. You need to drag this out and press tab or right click this. Right click this. Okay, we're back. Geometry and a camera and a render. Also, we're gonna use a constant material. Sorry if I'm going too fast. Let's change this camera's projection from perspective to orthographic and ortho width of 1. This render should have the same resolution as we set here. And Y, there it is. And now we can turn our instancing on and use this for our transition. And here we are on G. The camera isn't going in the right place. I could set this at bottom left, but I'm actually gonna keep it on center and change the translation here to 0.5, and on the Y it's gonna be 0.5 multiplied by our ratio. So copy the ratio here times 0.5. And you can see same result, but with this I can change this to zoom in and out. I'm gonna keep that 1.01 just to have a little bit of an edge around. Okay, cool. So we're instancing all of these rectangles. Now we need to create the textures that are gonna go inside of each rectangle, and that texture, all those textures are gonna be the sine waves that we want. Let's add a base. And I'm gonna make textures. I'm gonna change its color. And now let's go inside of here. I'm gonna select, we need a lot of, a couple of our parameters. So from a dot null data, there they are. And we need here the levels, the dial ratio, the min cycles, and max cycles. And we are gonna use the replicator comp, really useful comp for a lot of things. And this takes in a master operator, so let's add a base. I'm gonna call this item 0 and drag it here to master operator. You can see the operator prefix is already item, and instead of by table, we're gonna create it by number, and the number is gonna be these levels. Levels, but -1. As you can see, they are here, and we have 10 levels, and we have 10 items, because this one is also included, so we don't waste computing on one. And okay, so we can go, well, this is what I meant by levels before. So the levels sets the amount of different waves that we're gonna make. So if we had 2 levels, we will only have one really low frequency and one really high frequency. So you can think of this like when you use a limit tab to reduce the amount of different colors an image has. Well, in this case, instead of colors, we have a different amount of different waves. So a higher amount of waves will give you smoother gradients, and lower amounts will give you like a kind of quantized look, if you know what I mean. Okay, let's go inside of this item, and again, I'm gonna select here a bunch of stuff. So from the select we had before, now inside of here I actually need all of them. And also I'm gonna add here a different constant for time, and this is so that we can control this time variable with whatever we want. In this case, I'm gonna just use apps time.seconds. You can use, a speed chop or whatever you want. No time. And I'm gonna select here. So double period, and then no time. There it is. Okay, so let's use a pattern. There's a sine wave. You can see this number of cycles controls the frequency. This is what we're gonna control with this parameter. The length, I'm gonna set it to 500. You don't need that much resolution for this. And let's calculate our frequency. So we have these minimum cycles and maximum cycles, and that should go from the first item to the last item. So A way we have in TouchDesigner to tell which item we are in is to look at the digits of the names of each one of these bases using Python expression. I'll call this digits, which is this. If I can go parent, which references the parent operator of where I am. So in this case, it will be this base because it's the parent of this constant. Parent dot digits, and in this case it's 0 because it's looking at this number right here, and it will do so for each one of them. And we know that 0 goes from, in this case, 0 to 9, so it goes from 0 to the levels -1. So I'm going to use a math here to change this. Instead of from going to 0 to, from 0 to levels -1, I want it to go from our min cycles to our max cycles. There you go. I'm going to rename this. That wasn't it. Rename this to cycles. And number of cycles. There you go. Also, I'm going to change the channel name to TY. And I don't think I need to do. Oh, also we can animate this using our time into the face. Now it's moving. Also, I want to add a little bit of noise here to add some character. I forgot to add the amplitude here should be 0.35, and this noise, let's change period to 2, roughness to like 0.35, amplitude 0.3 or 0.28, let's say. And we can add these two together with a math and combine chops add. Also look at this, this is a different length from what we set here. We actually need to change this outline to stretch to first interval. So this noise is going to get stretched so it fits this wave's interval. Okay, cool. Now I'm gonna make this shape so it's a little bit rounder, and the ends, the ending and the ending and the beginning are at 0, so that each wave can connect into each other. I'm gonna add another pattern, also length 500 and number of cycles 0.5, so we have this nice heel, and we can multiply these two together with a math, combine chops, multiply, and now the start and the end are both at 0, so all of them can connect to each other. You can play around with this, maybe you don't want them to connect, but this also gives in a nice well, this shape and round. Okay, also here in this math we can scale this wave by our tile ratio, and for now that's it. I'm gonna add a pattern to, because this is ty, we need tx. Let's change to tx, and in these combined channels append, so it gets added, and this should be a ramp that I'm gonna offset by -0.5. So this goes, oh no, -0.5. So this goes from -0.5 to 0.5, which center at 0. Chop to stop. There it is. It shows a warning here because there's no set. But I'm gonna just delete that since we don't need it. The warning is gone, and we can render this via geometry, camera, same as always, render, and let's get a line material. There it is. First, this renders resolution, or the aspect ratio should be the ratio of our tile. So I'm gonna make it so I'm gonna drag this here. So it's whatever value its width is set to multiplied by our ratio. I'm gonna put it here just to copy it times this. And we can set the resolution to something way lower, like 520, 512. Since it doesn't need to be that high resolution, since the tiles are gonna be real small, you can change this around. The camera, I'm gonna change the projection to orthographic and ortho width of 1. And this line, I change the color to white and the width to like 20. Much better. Okay, now we have this first wave. I'm gonna set this to an out. Now we can see it here. And let's recreate all operators. So everything that's built here is gonna get copied to all of the other 9 bases. But since we made this, so it is procedural based on the digits of each of the bases, they won't have the same result. Oh, I also forgot this noise. We can use the digits themselves as the seed, so every one of them has a different noise. Let's recreate them all, and there they are. So the first one has the frequency of our minimum cycles, and the last one of our maximum cycles. You can see here, it's 10. Okay, so these are the textures we're gonna use for our instances. And to tell each instance which of these ones should it take, we need top that has all the indices. So the top that has values that go from 0 to 9. And those values could be based on whatever image or text or video or whatever. I'm going to use a noise that has same resolution as our final image. Very important that whatever input you choose has the same resolution. If you want, for example, to use a movie file in, you can fit it using that resolution. And also it will be helpful to turn it into monochrome with a monochrome. Okay. But here, I'm going to use a remap to use these values before the math to remap this image. So remap this image using these values. Let's change the resolution source to UV. And these pixels for us should be 32-bit mono. Okay. And you can see it's kind of the same image but stretched out. Let me change the lower the harmonics. And this with a math, instead of going from 0 to 1, it should go from through 0 to 9, right? Because those are our textures. So it should go to from 0 to our levels minus 1. 0 to 1, go to 0 to levels minus 1. And these are indices, so I'm gonna round them off so they are integers. You can see all those numbers right there. I'm gonna select all of this and change the smoothness to nearest pixels. And there's null, and let's change that to null index. I'm gonna change this one as well to nearest. So now we can use this for our instancing. So sorry about that. Instancing, instance second page. All the way down here, there's instance textures, texture index, OP, and texture index. So instance textures is all those textures. So to reference those, we're gonna first go to our base, which is textures, then slash. So we're going inside of that, then item, and an asterisk. Asterisk in this context means just anything. So it's going to look at any operator that's name item and then something else and whatever it is. And in this case, it will be these 9 items, right? And then inside of each one of those, you're going to look at out1. And look at that. We are seeing waves. So right now, these are all just looking at the one at 0 because we're not providing it with any index. We're going to use this operator right here, our null index, as our index operator. And the texture index is going to be R, the red channel. And there it is. It's moving and all the waves are connected to each other. And you can see this corresponds. You can kind of see it. If I change this to the banana, you can see it better. To our input texture. Okay, let's add a little line, dotted line around each one of these because I feel like without it, it looks like the whole thing is moving, which you can also like. I'm gonna copy and paste this, but inside of this second one, I'm gonna get rid of this instance texture. Right there, and we're gonna use a different material for this one, a different constant, which I'm gonna set to wireframe, topology wireframe. You can see it's now only the wireframe, and for both of these, I'm gonna turn on the blending transparency. And now you can see it. And to make it dotted, I'm gonna use a ramp. I'm gonna have this ramp be the same ratio as our tiles. So same as before. First, I'm gonna reference this. Then I'm gonna put this here just to copy it and multiply this together. And this can be like a real early resolution. And I can transform that, rotate it 45 degrees, change the type to repeat. Also, I can change this ramp period to like 0.7 or something really small, and use a threshold. So now we have lines. Color map, and just drag it in, and now we have dotted lines. Cool. Okay. So now I'm gonna add some post-processing. I can add a lens distort with like 0.2. Let me add a null at the end so we can see what we're doing. Also, we can change the color of both the waves and the grid. I'm gonna just put something like green, and here as well. And also I can add a transform, add 1 to the alpha, composer background, so we have a nice black background and some bloom that looks nice and glowing. Cool. Okay, so this is the basic system, and it's all procedural. You can change this on the go, and the grid, all of that. You can also change the resolution, maybe something widescreen, that. Looks very good. Okay, so now I'm gonna make this audio reactive. So first I'm gonna just drag in the an audio file. I want the audio file in. This is the one of the default songs that TouchDesigner comes with. Let's listen to it with an audio device up. I'll lower the volume a little. Okay. And let's prepare this for processing. Let's add a math with combined channels average, rich, and then we can use audio spectrum to get this spectrum. And here on the output length, we can change this to the length segment manually to make this a nice round value that's not so big. And set it to 1000, and we can just make a null and call it null audio. Okay, so I'm sure there are many different ways of making this audio reactive. You can let me know if you find a different one or a better one. This is what I came up with. I'm gonna divide this spectrum into the amount of parts, that is the amount of levels that we have. So in this case 10, so I'm gonna trim this out into 10 different chunks, and each one of those parts of the spectrum I'm gonna control each one of the waves. I hope that is clear to understand. So let's go into our waves right here, and I'm gonna select the audio with we're going up the chain twice and then null audio. There it is. And now we're gonna trim this. We're gonna trim, and this needs to be on each chunk per se. So we're gonna change this to fraction and fraction. So in this case, we have 10 levels, right? So each chunk is gonna correspond to a tenth of the entire spectrum, so 10%, right? This trim works by, let's change to absolute. If the start is a 0 and the end is a 0, then it's gonna go through the entire thing. And so we need to make this so it only goes from the start of our chunk, depending on our digits, to 10% more than that. Okay, so first we're gonna get what is the width of in samples of our chunk, or in this case in percentage, by dividing 1 by our levels. So in this case, we're going to divide by 1 by 10, so it's going to be 0.1, right? So 10%. 1 divided by levels. There you go, 0.1. And we multiply that by our digits. Let's put that there just to copy and multiply that. So the one with digit 0 is going to start at 0, the next one is going to start at 0.1, the next one 0.2, 0.3, and so on and so on. We can copy this and paste this here, and instead of multiplying this amount by our digits, we're going to add parentheses to both sides of here and multiply by digits plus 1. Very important, those parentheses. And there we go. You can see we are just getting this first chunk, this first part of the spectrum, this lower part of frequencies. And now we can transform it into a normalized value that we can use For scaling, when I use the billion trick, I guess their nick, with with an analyze here with average, and then an envelope that is set to the maximum range, and we can combine those two by dividing them. It should be the other way around. There you go. And combine shapes, divide, and that is a value between 0 and 1. We can then use to multiply our scale of the wave. So we're gonna add another math, and in this multiply parameter we can drag this here, and there it is. Now it's react to music. Something that happens here is that if there is no audio coming in, there's this error that comes up because this is referencing something that doesn't exist. And I don't like that happening, so I'm gonna add a little bit of Python here to take care of that. First, I'm gonna remove this channel 1 and just set it to 0. So you're gonna just look at the first channel of this null, just because we don't know what the channel name of this is gonna be, right? It may change, and we want it to be indifferent to that. And I'm gonna copy this, and we can do a Python expression to check if it exists. So I'm gonna say, so this value, this is what it's gonna be if the value itself. So this is meaning that it's gonna check if this is an actual thing, if it points to something, and if it doesn't, so else, just multiply by 1, right? So there you go. Nothing changes, but now if I bypass it, there's no error. Cool. Okay, now we can recreate all these operators, and there they are. And now it's reacting to the music. And you can play around. Maybe here, instead of just straight up the value, you can first add a math to rearrange this. Maybe you don't want it to go all the way to 0. 0 to 1, we can make it like 0.3 to 1. And again, recreate. And now the waves are turned off. They still show a little bit of movement. I think that's it. You can, play around, do a lot of things with this. I hope you enjoyed it. Again, the file for this project will be in my Patreon. I really appreciate your support. If you can support me that way, please subscribe to this channel to see more videos like this. Leave a like if you enjoyed. And if you have any questions, please feel free to ask me in the comments. And if you make anything with this, please send it to me or tag me on Instagram. I'd love to see what you can do. And I think that's it. Okay, thank you.